Hello again, YouTube. Welcome back to another Adventures in Coding video. First off, I'm sorry for the delay. I know it's been quite a while since the last video. Believe it or not, I have been very busy. I've been working on, obviously I've been busy in my personal life, but I've been working on a bunch of coding projects in the game. I made the maybe poor choice of deciding to have a level in the game where the game turns into a top-down racing game. And that really slowed me down for a while. I was working on Bezier curves and all sorts of nonsense. So that took up a chunk of time. And then, like I posted on Twitter, I was thinking the next video I was going to do was going to be on SDFs, signed distance fields in text. Really cool stuff there. A lot of people have kind of commented on that on my text rendering video, asking about that. And I spent a bunch of time. I really worked on it for quite a while. And in my game, I found I wasn't getting very noticeably different results, just because I think in my game, my theory is the issue isn't that my textures are too low resolution for the text. My issue is aliasing on the screen. So I messed around with that for a long time, and I ended up kind of shelving that. And I thought today we would come back with our particle shader and kind of work on the next step. So, with all of that being said, I guess the last thing I wanted to mention before we get into it was just thank you all for watching and supporting. I see all of the subscribers, I see all the comments. It really, really means a lot. So I just wanted to thank you before I begin. With all that said, today we are jumping back in with our particle shader. We're going to kind of make a big leap forward in terms of the structure of our code. Functionally, not too much is going to change really by the end of this video. We're still going to have the same smoke happening, but we're going to make a lot of improvements. We talked about this last video, but one of the main things we're going to do is instead of relying on doing all of this work of making an array of matrices, sending in our textures and having an array of colors and an array of kind of our instance order. Instead of doing all of that, we are going to today work to send our particles to the graphics card, to the GPU, to be able to be utilized. So we're going to have a SSBO of particles that we send in and we'll be able to use, which is kind of a neat step forward. It removes, obviously, these limits of like we have this hard-coded 200, which is good. We're also going to work on the lifespan of our particles. So we'll stop drawing particles if their life is over, and we'll also set it up so we don't run out of room. Because right now, after 200 particles are added, we max out, right? I don't know if we've even run it long enough to see if we get errors or not. And I guess the last thing I'll say, we'll keep cleaning and improving our project. So with all of that being said, let's jump in. The first thing we're going to do, so if you guys remember from our last video, we kind of set up some data structures we pass to our shaders in order to be able to draw all of our particles. So for instance, we have this array of matrices, or this vector of matrices, this vector of colors, and this kind of instance order to texture that we set up and maintain. And these are kind of a hassle, both because they're limited in size because they are arrays. Obviously, we could switch these to SSBOs. That is an option. And we'll kind of explore the pros and cons of this as we go. But it's a bit of a pain in the butt that we have to keep doing all this extra work. And really, I like the idea of, just from a conceptual standpoint, from a design standpoint, I like that if we can have our particles sent to the GPU, we can kind of do what we want with our particles. We can modify them, we can create them, we can delete them, and we don't have to kind of keep these data structures outside of all of our particles up to date. We don't have to do all of this rigmarole of keeping these structures good. So what we're going to start off by doing is we're going to actually declare a struct in our vertex shader for the particle. So we've kind of done this before with handles, and I think with our text rendering a little bit, but what we haven't done, I don't think, is instead of using a language-defined type, creating our own data structure, or our own struct in this case, and passing it. So this is going to be something new. So what we're going to do is we are going to take this set of data, which is part of our particle, and we are going to declare it in our shader, on our GPU code. So up at the top here, we're going to go in and we are going to add this struct. I'm going to call it particle. I guess to be consistent, I'll use a lowercase p. So you may be watching me do this, and depending on your knowledge base, especially around struct packing, you might be watching this and saying like, oh God, this is going to be an issue. We're going to get there over time, and we're going to talk about that a little bit, of kind of the issues that can come along with our current approach. But we're going to wait until we actually encounter that problem. So this GLU unsigned int 64, we know from here that that should actually be an unsigned vector 2. Okay, so we have our particle now. Now, similar to what we have here with our texture handle block, we're going to do something very similar. We're going to add a new buffer. I'm going to increment it. We'll call it our particle block. And it is going to be particles. So that's nice. We now have a SSBO declared of particles, and we can start to update our code here. So first off, what's really nice is because each of these particles has the matrix inside of it, its transformation inside of it, we can get rid of this array. Okay, so now instead of using m at GL instance ID, we're going to do particles. You'll notice I still have these m's in front. To be honest with you, that's mostly me being lazy. That is the style I like to use in C++. I don't know how common that actually is in GPU coding, but okay. So we have our position and our coordinates. And now we're going to update this to kind of pass stuff along, because along these lines, we are going to remove a lot of the data in our fragment shader, actually. So the color, obviously, we don't need an array of this anymore, because we're going to get this from our individual particles. As well, we're actually going to move to sending our textures with these particles. Now, this is actually, in terms of memory being sent to, or data being sent to the GPU, this is actually going to be a little bit less efficient, right? We've kind of talked about this in our other videos, but because we have this array, we only list out each handle once in this texture handle block, right? So it's like texture 1, texture 2, texture 3, and then this array is full of my fifth particle uses texture 1, my sixth one uses texture 2, right? And it avoids that duplication. So we will actually be sending a bit more data with this change, but it's not the end of the world. And it's actually very cool doing this, because before we were using bindless textures, you always have to bind a texture, right? Even with this, I know we aren't technically binding textures, but we're sending all of our textures almost as if it's a texture array, right? Or a sampler 2D array, I should say. Now, with this change, each of our particles has the handle right in it, and we don't actually bind that texture. It's very neat how we can just send these textures we want to use. Okay. To go alongside this, we have this information in our vertex shader. We're going to have to pass it to our fragment shader. Now we could keep going through and adding individual out variables here. I'm going to make a struct for this, just because it's a little bit more efficient and it's good to group them. I'm going to follow that learn OpenGL structure. Okay, so we have our index. I don't know that we're actually even going to need this anymore, because we're not going to be using this, we're not going to be using this, we're not going to be using this. So we don't need our index anymore. So that one's going to go. Our coordinates we do need. And we also need a couple other items. So we are getting our color from here. So we will add that in. I'm going to make this flat because presumably that color should be the same across our particle. Next up, we're going to use the life here. If you remember in our last video, we talked about how we would like to use life. So if you try and render a particle that's life has exceeded its lifespan, you don't actually render it. Add that. And the last thing we're going to add is our texture. These guys are both flat because the life should be the same across all of the vertices in our particle, and same thing with the texture. It shouldn't be using two different textures across. Okay, so we don't need that anymore. Our coordinates is now going to be just out dot coords. So for our life, because right now we are sending our life and our lifespan, and our life goes up over time, and our lifespan is the limit, we're going to subtract the lifespan by our life to see how much time is remaining. Excuse me. Our lifespan minus our life. Okay, so this will be a number that goes down over time now over here. So we can just say if it's greater than 0, we do our rendering. The last item here is our texture. Excellent. Okay, that looks pretty good. I'm going to move this guy up a little. Period. Nice. I'm going to take our struct here and I'm going to move it over to our fragment shader because we will need it. So we're getting rid of these guys. This is going to be fs in. So first off, we are going to add in a discard. Just like we discarded before if the transparency was 0, we are now going to discard if the life is less than or equal to 0. Okay, so this means now, obviously, in an ideal world, we don't send particles when their life is over. But now with this, we know even if we send a particle and its life is over, that's okay, we won't render it. So that's good. Now, what's really cool, like I was talking about, we can just send that texture in there, which is really nice. Warrant. Cool. All right, that looks pretty good. So with that, we have our particle added. Now, obviously, we're going to have to do some work on the C++ side to make sure that we send this over and we're setting all of the correct data. So we'll switch over here. All right, where to begin? There's lots of stuff to do here. First off, we are no longer holding on to an array of our colors and our matrices, right? We can remove those from our particle system. We are no longer holding on to an instance order. We can remove those. And we can even remove our texture handle map because we're not going to be sending those anymore. Big cleanup. Now, we've removed those. The one thing we do want to add is instead of having this SSBO for our textures, we are going to want one for our particles, right? So we'll update this to send that data instead. We're going to remove add texture because that was what would add to our vector and our map. We don't need to do that anymore. And when we flip over, we should have some errors from all this. Okay, so let's start with add texture. We're just going to remove this. We don't have those items anymore. We don't need them anymore. So we will pull them out. Now, as much as there are drawbacks with this, hopefully as we go through here, you're starting to see the benefits. So before, every time we added a particle, we had to add an item in our matrices or an index in our matrices, our colors, we would add those textures. All of that is going to get removed because our particle is going to contain the data we need. This looks okay up here. Here now, we are going to, actually maybe I'll leave this because we can reuse some of this code. Obviously it's going to be different, but we can copy and paste to set up our other SSBO. Our update we can also simplify. Let's start at the top here. Okay, so we are no longer going to create a SSBO for our particle textures. We are going to do it for our particles. So we do all the same binding. Now you see I did in my shader declare this as binding 2 just because we had binding 1 before. I could really set that to 0 and just set that back. It's not really going to matter too much right now. We're not really struggling with that. So instead of sending one GL int or unsigned int 64, we are now sending size of a particle. And then for the number of particles we're going to send, I'm going to create a const int for this. It was a good idea instead of having these numbers hard-coded as much as I just had that, but maybe we'll make it public. I don't know, particle array size is equal to 1,000. Okay. Maybe we change that to like buffer limit. And here we will just swap those in. Okay, so our SSBO is now allocated to hold on to an array of particles rather than those handles. Our update here is going to get simplified. We don't need to change those two arrays anymore. So I'm going to remove these guys. And because we don't need to hold on to those anymore, we're no longer really needing to return a bool with our update. You can see VS assist for me tells me how you can convert that to a range-based loop. We don't really need to do this. It's not going to break the world, but it might be a good idea. We're going to update these to no longer return a bool. Just because we're not caring anymore if we need to update. So just call matrix. And in here, just pull these guys out. This is one of those things, it's not really going to break anything. It's just kind of good to clean it up now while we're looking at it. Okay. Let's go back to our particle system. So we're no longer going to be binding that other buffer. Before, we only wanted to do this when textures was not empty. Now, because we're only rendering when we have particles anyway with that check, I'm going to pull that out. We will attach our SSBO, and instead of textures.size, it's going to be particles.size, and it's going to be okay. Now we can also pull out these two arrays. We're not going to care anymore about that, which is good. And instead of matrices size, we'll do particle size. That looks pretty good. So I just want to make sure. So our emitter update goes through, creates our particles with the emit function, right? And with every single particle, it grabs a texture handle from our textures array and sets it. So our particle should have our handle already. That looks pretty good. I'm trying to think if I've forgotten anything. Let's give it a run and see what happens. I can tell you already, I hinted at this before with the struct packing conversation, but there is going to be some issues with this. So we'll try this. Just want to make sure no errors. Oh, vertex on 22 here. Oh, I missed a semicolon there. Okay, on the fragment. What did I do wrong here? Oh, this is in now. There we go. Okay. Now, I have no idea what's going to happen with my OBS recording while this happens. You can see the memory is going up and up and up and up and up. So I don't know if I just hitched there or if it was recording smoothly. I guess to be honest with you, while I was working on this, not recording, that would happen a lot. I'm going to try to avoid doing that just because I don't know what that'll do to the OBS recording. The reason why we are having our memory just spike like that and it's not working the way we expect is we're actually having an issue getting the texture we expect. The reason for this is around our struct here, and it's around struct packing. So this is kind of a concept, it's very prevalent in C++, but it's a concept that with C++ oftentimes you don't encounter unless you're trying to optimize or you're trying to write super efficient code with C++. So it's very possible to be really proficient with C++ and not really have had to worry about this because functionally, for the most part, you won't encounter this. It's really more of a performance thing. However, now trying to interface our C++ with our OpenGL, we're encountering an issue. So struct packing is kind of a big concept. There's a lot going on here. I don't want to get too in the weeds, especially because this really isn't an area of expertise for me. But with C++ and structs, there's this idea of memory alignment. So in essence, your memory, if you have a 64-bit computer, which most likely you do, it's very common since Windows 7 for a long time now, C++ wants your structs to align with 8 bytes. So we can see here with this example, someone has made this sample struct, Carlos Vin, I guess, to give full credit. Carlos says blah, blah. In their example, they make this struct, they have a bool, and they have an unsigned int. So they've gone through and written here that the unsigned int is 4 bytes worth of memory, and a bool is 1 byte worth of memory. So if you imagine having an array of this, in a perfect world, this is 5 bytes of memory, right? You would imagine we just fill up our memory, just one sample struct next to the next sample struct next to the next sample struct, right? Because we don't really, like, it makes sense. Arrays are supposed to be contiguous. They're supposed to follow in one solid chunk of memory. But the issue is because our memory is 8 bytes, this causes a bit of a problem for C++. And there are a lot of ways around this. But just inherently with the language, this comes up. So with this struct made here, as much as it should seem like there are 8 bytes worth of data, or 5 bytes worth of data here, C++ is going to make it 8 bytes. And the reason for that is there is that 3-byte gap where you can't just slip in the first 3 bytes of the next variable the next object into memory. So C++ slips in these 3 bytes of padding, we like to call it. And they kind of go through a code example here, and they say they have that bool, they have that unsigned int, and they print out the size of just the flag, which is 1 byte, the size of this timeout, which is that int, which is 4 bytes. You add that together and you would expect 5 bytes. However, when you print out the actual size of that sample struct, you get 8 bytes. So this is the concept of alignment. So there's different ways around it. You can use pragma-pack. Typically, if you just order your variables largest to smallest, it's going to do a decent job around this, but this is something that people really do spend a lot of time thinking about, especially if you're making a game engine. You can just utilize your memory a little bit better. Okay, that spiel down. Why is this a problem with C++ between OpenGL and C++? Right off the bat here with this struct, you can see we have an offending problem here. So a vector 3 is 3 floats. Now, with our memory alignment, we kind of want 4 floats to take up a whole aligned section of memory, right? With this, because C++ is going to put padding after that vector 3, the next vector 3 is going to be in the next row of memory, right? OpenGL is expecting this one in the next spot. At least that's my best interpretation of things. And so we need to make sure our struct is memory aligned. As well, I will call out, I am very much not an expert on this, but there are different memory alignment options with OpenGL. There's 430, and there's also, I think it's 142 or 140, which will alter kind of the way this works. So we're going to go through and we're going to add our padding in here to make sure this works. But you can already see already, we don't need all of this data, right? We don't need the position, we don't need the velocity, we don't need any of this stuff, right? So after we get this working, we're going to optimize this to make it so we aren't sending as much data. Because you have to keep in mind, every single tick, every single update, we're sending all of this to the GPU, and it can be very inefficient. So there's a couple things we can do here. The first thing is, as I mentioned, we want to have 4 floats to fill up a column of memory. Well, first off, we already have some extra floats lying around here, right? So what we can do to start is we can take our life and put it here. So this is now a full memory aligned section. Do the same thing with our lifespan. And this is when we kind of run into some trouble, right? Because, I mean, we could use our bool here, I suppose. Maybe we'll give that a shot. I didn't do that in my example, but we'll give that a try. But now we need to start introducing some padding. So right now, I'm just giving these letter variables because we're not actually doing anything with them. Obviously, as you're looking at this, you should be thinking, boy, this is like a huge waste of performance, right? Okay, this one's going to be good. These guys are good. Now our texture here, I think we're going to need 2 of these. So I wonder if this is actually any benefit compared to what I did, or maybe it's the same. Okay, let's take a look. All right. Now, because we are copying our C++ memory right over, we're going to have to make sure that we match. So we had our life here, we had our lifespan here. I believe we put our acceleration or transform change underneath, and then we started with our letters. Now, I do just want to be clear, I'm trying to set this up to get this to work. There are ways around this. You can tell C++ to not do this. You could probably on the OpenGL side do something about this as well. But I just figured this is kind of an interesting topic, a good excuse to get into memory alignment and struct packing and kind of demonstrate this. So let's give this a shot. As I say, I didn't put our bool in here. We'll see if this works and see what we get. Oops. Okay, our memory isn't spiking. I guess the one thing I didn't explain, we're going to figure out what the problem is here, but the one thing I didn't explain, the reason why this causes issues is the OpenGL is going to try and use that array of particles, right? And because our alignment is off, it's going to get confused. So maybe like it thinks it's a position, but it's actually the texture of the last item or so on. And so you get really wonky values, and it can be kind of dangerous to be getting these random values coming in. Okay, so let's first see if we're getting anything out here. Color is equal to vector 4. Are we getting any particles? We are. Excellent. Okay. What about if we do our sample? Okay. So we're losing it with our textures. Let's make sure we're doing everything right here. Are we passing our coordinates properly? Yeah, it looks like it. We're using them. Oh, of course, I never set that color. Foolish. Okay, let's try that. There we go. Okay. And we can add these back in. There it is. So what do we kind of learn from this? Well, this is another one of OpenGL's really fun quirks that, you know, you think that you should be fine with that code. I mean, obviously we did have the issue around the color that was present, but that memory spiking was happening because of the struct packing. And this is one of those frustrating things with OpenGL where there's no alerts. No one is saying, hey, this is a problem. So we're going to work on this. We're going to actually make a new structure on our C++ side, which only contains the data we need. What I will highlight while we're talking about this is we can adjust our particle here to be more memory efficient as well, right? So I'm going to remove all of our fake values, all of our padding. Okay, so I'm going to put this guy up here. Okay. Is this perfect? No. Like we can see already here, we have some issues with alignment, but this is going to help to improve things a little bit. It might not even change things all that much, but having our life in here is actually going to improve things. And if you really want to mess around with this, as I say, there is the ability to add those pragma pack instructions, and GLM actually has some rules around this, which can impact things. But if you really want to mess around with this, you can actually just do much like that link I had up did, size of. So you can test, you can try moving stuff around, see if it actually improves things or not. And there are, I believe there's even libraries around this, which will try and pack structs for you. So I'm not too concerned with this. This is all right. What we're going to do now is we are going to make a new struct to hold on to just the data we need. So this could obviously be better. It would improve our C++ memory usage. But right now we're just focused on that passing the data over to the OpenGL. I'm just going to switch my code example. All right. So we are going to make that new struct. I like to, this is kind of just the name I've gone with. I don't know, maybe there is like a better name that people use typically, or a more standard name, but I like to call these classes when I make them stripped, because I'm stripping out unnecessary data. We don't really need the public here because it's a struct. It'll default to public, but I'm going to add it. So what information do we actually need here? We need the color for sure. We need that matrix for sure. We don't need the coordinates. We need our texture. We need our life. And that's about it. We can really pare down this data. And the key thing to remember, once again, the less data we have to send per particle, the better, because every single particle we render on every update, we are sending that amount of data per particle. So cutting this down can be quite beneficial. I'm just going to start with these. So we have our matrix, we have our color, we don't need our start and end. Position. I'm going to get rid of lifespan as well. We're just going to send life going down from the span to 0. That'll make our life easier on the shader. Okay. So I'm going to do a swaparoo here. Now, this is going to be column aligned because it's a bunch of floats. This is going to be column aligned. This is 2 floats, 1 float. And now, actually that unsigned int 64 might even be more than 2, but we're going to have to add in 1 item for padding. Okay. And I'm going to copy that back over on our shader before I forget. Okay, we'll get rid of these. Excellent. Let me check that. That looks good. So obviously the thing we need to do now is, instead of sending our particle, we need to send our particle stripped, and we need to make sure that our information is transferring from the particle array to a particle stripped array. First off, what am I going to do about this? We're going to go to our particle class. We're already in, and we're going to add some functions for this. We're actually going to do a couple things while I'm in here. So first off, around the life, I'm going to make this public. It'll make it so we can access it more easily. We might not even need it, but we'll see. Yeah, let's leave that out, actually. I don't think we need that. So first off, around life, we are now going to set our life to the lifespan. So instead of counting up, where we add delta time to life, we're going to start at the lifespan and count down. That way it's easier on our shader. We can just say if it's below or equal to 0, ignore it. So this will start it at our lifespan. And in our update here, we're going to say minus equals delta time. Our logic here around the clamp, we just have to invert that because we've switched. Otherwise, we will start at the end color and move to the start color. So we'll swap that around. That should be about it. That'll make our code a little bit easier. Now we can just pass that life on. The other thing we need to do now is some logic around the stripped classes. So I'm going to first off make a class or a function, a method really, to stripped. To stripped. So what is this going to do? This is going to take this particle class and create a particle stripped class and return it. Pretty straightforward in here. We're really just returning all of our values. You've seen it before. I really like to use these brace brackets that vAssist has taught me. So we're going to return M. This is going to be the same order we've defined here. So M, color, texture, life. Okay, so that will create a new particle strip. Because we want to try and have good performance on this, the other thing we're going to want to do is not just create one, but also update one instead. I don't know why that's upset. There we go. So initially, when we add a new particle, we can create a new particle stripped, but after that, we shouldn't be creating them every time because it's going to be bad for performance. So update stripped, we'll take in a particle stripped. And in here, same type approach, we're just going to say and there's even things we can do around this, right? Like, what's the likelihood the texture is actually ever going to change? Pretty low. It's not really like an obscenely expensive thing copying that bit of memory, but you know what I mean. Okay. Nice. So that's good. That means from our particle, we will be able to transfer data from a particle class to a particle stripped. Now, we need to start working on this so our particle system holds on to particle stripped as well. So underneath particles here, I'm going to add another vector. Okay, and we're going to try and keep these two in parity. So if there's 5 particles, there's 5 strip particles. And flip over. Now, when we add particles here, we are going to do our to stripped, right? Okay, so that'll mean anytime we add a particle, we are also adding a strip particle, which is good. And because we're using this add particles function, that'll happen. That'll be covered everywhere. Up in here, we no longer want our SSBO to be size particle. It is now going to be particle stripped. Okay. And over here, we will do the same. Nice. And when we update here, whenever we update and our particle changes, we're also going to have to say i.update stripped. I suppose we could put this all in the update function and just pass that as a parameter, but and we'll have to switch this back to index-based. I know we just made the swap, but Okay. So I ended up doing 2 changes at once here. We got one more change we're going to go through together before we're done. But I'm interested in if we can just get this going with just that strip change. So let's see what happens when we run this. So we're not spiking, which is good, but actually let's make sure. Was there any errors in the console? Yes. 7. Like my 2. Oh, this needs to be. There we go. Let's try that again. Okay, still nothing, no spiking. Lifespan, right. Whoopsie daisy. So because we are no longer doing this logic with the lifespan, we can just update this. So we just send the life on. Beautiful. It's working. Excellent. So now we're saving on the amount of data we're sending across. And I can even, let's grab, do I even have that code anymore? Let me grab that code. Just so we can see the difference. Breakpoint. Okay, so the size of our particle, 216, particle stripped, 96. So a big savings. And you got to keep in mind that's going to be multiplied by n. That's going to be multiplied by the number of particles. Okay, so I think I have one more thing I want to cover with this video. The last thing we're going to do here, our shader is now somewhat aware of the lifespan, right? As particles age out, we no longer render them, which is good. What I want to do now is I want to set this up so when we run out of space, we start to loop back in our system. So what I mean by that is we've said we can hold on to 1,000 particles and our array size should really be limited to 1,000, where right now we can go beyond it, right? What we want to do is have an array, and when you reach the end of the array, we loop back. And in a perfect world, those first indices, the life will have already expired, so you'll be replacing dead particles. If you have a particle emitter that's emitting too fast, you'll just be replacing the oldest particles with that, or give or take the oldest, because we are using some random numbers. This is one of those changes that right now, it does make it so we don't run out of space, which is good, but it might not seem super useful. As we keep going and we improve the system, this is going to be very helpful. So I'm going to add 2 variables here. Unsigned int array size and an unsigned, oops, not a union, int. I'm going to call this tail for now. I've kind of messed around with this, and we'll talk about more in specifics why I named it a tail. And the thing we're going to update as well is now when our particle system gets initialized, we are going to specify how large our array should be. Should probably really call it a vector size, but. So our array size is going to be equal to array size, and I am going to allocate that array of particles right at the jump. So we'll stop using that in place back, and we'll just be accessing indices. Okay. Oops. Now back in main, when we go to initialize, okay. Now to go along with this, we have to add some changes. So first off, we aren't in placing back anymore, right? Whenever we want to add a particle, we are going to add it at tail and we are going to increment our tail. Okay. That looks good. Now, because we have that whole array allocated right off the jump, right? Our particles here, it's going to be hard to decide if it's empty or not because it's already sized, it's already allocated, right? Instead, we are just going to do our full array size when we do our render. I'm going to talk about this a fair amount because there is a lot that kind of goes along with this. There's things we could do to improve this, and I want to explain that decision, but okay, that looks good. I think I got everything. So we're only getting one right now. Oops. This needs to be modded, not and. Okay, so with this change, I should be able to hold down the spacebar and create so many particles at once that I start to have to eliminate old particles. And so what we should see is some of the higher up, the larger particle smokes should start to disappear quickly because they're being replaced. So you can see it's almost like they're being eaten up to create more ones in front. And you'll also notice our performance is flat. Okay, so there's a fair amount to talk about here. Right now, we just have this big vector, this big array that is allocated in advance, and we just start looping through it whenever we want to create a new particle. Obviously, one big downside with this is we are constantly drawing our full array size, right? We are drawing 1,000 particles at once, which is not really ideal, especially when there's only 3 particles that should be drawn. That is definitely a drawback with what we have right now. Something we could do to improve this is we could actually switch to a ring buffer. So instead of having this array where we just have our tail that loops through, we could also have a head. And what the head would do would be every time a particle dies, its life goes below 0, you would move the head up. And so instead of constantly drawing the whole array, you would just draw what is between heads and tails, or the head and tail. I started to work on that and it got a little bit complicated, and I really wanted to focus on kind of the graphics programming that is kind of a data structure. So maybe we'll add it in eventually, but that is one optimization we could do so we're not constantly drawing the full array. Something else you might think to yourself, what if instead of doing it this way, what if we start to sort the array by the lifespan? So we have our full array. Instead of allocating it all at once, what if we allocate it as we need particles, but we sort our array? So the largest life particles are at the start and the lowest are at the end, and then we try to add in where we can. And so we might even not need to keep growing our array because it might just bounce around. Particles might die at the same rate that you add them, right? It's a really good idea, and it's something I played around with. The reason why I'm not going to go with that is there's a common feature with particle shaders where you want to sort your particles by depth. So you render them depending on their depth on the screen. If we were to do sorting by life, we wouldn't be able to do that sorting by depth, which we're going to want to implement later. So that's why I didn't go with that. So it's kind of a breakdown of that. Maybe the next video we'll add in the ring buffer, because that would be kind of cool and it would improve our performance a fair amount. I think that that's most of what we wanted to cover. Maybe I'll kind of give some tips or like heads up on what we're going to do next. So it would be nice to have that sort by depth, like I mentioned. The one thing we are going to run into very shortly is right now you can have any number of particle emitters and they all emit to the same array of particles, right? And that's good and that's bad, where with what we have right now, if we were to have some features where the particles interact, maybe you have flames and you have smoke, we could sort those and have them all in the same array, so they will actually sort against each other. Whereas my particle system in my engine, I have individual arrays of particles for each emitter. And that kind of has some benefits, but it also has some drawbacks. The benefit is if you want to enable something for one particle emitter but not another, you can just do that when you go to render. So for instance, maybe you want your particles to glow, right? Maybe you want to have a blur on them. You can send a uniform when you go to render that particle that says glow is enabled, right? Whereas with this one array of particles, you have different types of particles interspersed. Maybe you have a flame that you want to blur and you have a smoke that you don't want to blur. So you can't do it as just a single uniform. You would have to send it as part of our particle. Now, obviously, we do have an open member here, this 2, that's useless, so we could do something with that. But it gets a little bit trickier when it comes to things like blending. So like, for instance, additive blending is very common. You might want to enable that with our shader settings, with our OpenGL code. That you typically do before you perform a render. And so if you want to have additive blending for one set of particles and you want to have standard blending for another set of particles, it's going to be hard to get both that way, right? And you can write your code in your shader to do it, but you're not going to be able to do, oftentimes when you set that up, there are these OpenGL calls you do before you render, right? So if you have separate arrays of particles and you have separate draw calls, you're able to toggle those on and off. So that'll be something we look at in our next video, blending options. I like the idea of doing the ring buffer. Depending on how much time we have, I'd also like to cover soft particles because that's a common topic people like to get into. And then I don't think we'll have time in one video, but I kind of mentioned it last time. It would be good to be able to import and export our particles, as right now our smoke is just this massive pile of hard-coded data, right? And it would also be good to use a library to have a GUI, so like an immediate mode GUI, like DRM GUI. That would be great to add as well, so we can do stuff more dynamically. But all later projects, all things we can add on to this. I do want to, as we're kind of wrapping up here, say thank you so much for watching and thank you for sticking with this. I'm sorry it took so long to get to this video. I promise the next one will not take as long. We'll be back much quicker. And we can keep this going. We're kind of approaching a point where this is starting to get better and better functionality-wise. It's getting closer to the end than the start, which is exciting. And I guess on that note, we'll finish up for today. So thank you so much for watching, and thank you once again for subscribing and liking and commenting. It really does mean so much. I don't have that much time these days, but it's something I really enjoy doing. And also, you know, stuff like struct packing. These are headaches where I've wasted a ton of time on these things, and it's really nice to be able to post code so other people hopefully don't have to. So thank you so much for all of that. With all that said, have a great day. Be sure to like, comment, and subscribe, and I'll see you in the next one. Bye.